Okay, so guys, this is part A of the MATLAB step-by-step at San Diego State University, summer 2020, and as I told you, we're gonna have midterm on June 15. So on this Thursday, say at let me see, at on 11th. So I'm gonna send you a Zoom link so you can ask any question that you can have, okay, from me. So I'm gonna be online from 2 to 2:30, so you can ask me any questions that you have by the Zoom link that I'm gonna send to you, okay? So at the 11th. So now let's continue our topic on the MATLAB, guys. So here we go. So I uploaded notes part 1 on the Blackboard, and you have my glorious notes. and we were here, that's right. Eigenvalues and eigenvector of a given matrix that I told you you're going to use it in the any courses, specifically on the vibration, robotics, nonlinear control, when you're linearizing around the Jacobian point, and you calculate the Jacobian matrix, and too many things, that's right? And on the graduate control at the same time, we can use it. So then we solved a set of the linear equations, as you remember, and like this. And now we are at the practice 12. Let us do that together, huh? So solve for x and y and z. So what you're gonna do, this is practicing that whatever I taught previously. Let me move it here. Okay. So and so here we go. And I'm going to close this. So I told you that this is a vector capital X. If you look at the part 7 notes on the YouTube, and this is the matrix A, and this is your matrix R or B, that's right, right hand side. So what you're going to do, you're going to define your A as 1, 0, 2, that's right, 99, 10, 2.4, and the next line is 0, 0, 1, 1, okay? And now R or B or whatever that you want. I'm saying that R means because this is right hand side, that's the column of 1000, 101, and 560. Okay, here we go. So based on whatever I taught in part 7, and go and find on YouTube, you can say that the solution gonna be inverse of A multiplied by your R. So this is 3 by 3, that's right. This is 3 by 3, and it's gonna be, as I taught in part 7, you have to be very careful. And this is 3 by 1. So 3 by 3, 3 by 1 gives you 3 by 1. So this is what you get. Okay. So this is your x multiplied by 10 to the power of 3. This is your y, and this is your z. Okay. So what if you want to see specifically this number? It's very easy. You say solve 1 on 1, because this is a vector, that's right, have 3 rows and 1 on 1. So now you can label it as x. I want to see the x. You can do the coding that I'm going to teach you later, okay? So this can give you your x gonna be bottom one, it's gonna be, so your y gonna be solve now second row and the first column, 2 on 1, that's right. Your y is this, and your z gonna be what? Yes, you guessed it, gonna be 3 on 1, that's right. So now let's go to this problem. This now again I have to define our A, which is the same here, and this is the same here, but only different is 0, the last row, that's right. And your B is the same as or R, right hand side is the same as 1, but here's 2000, that's right. So your solve again, as we have above, see here, so our solve is inverse of new A, and this is this time is infinity. Okay, Because why? Because the matrix is singular to working proposition. So let us see what it says, because it says that there is no solution for this, because your matrix A, that was this, I taught you in the inverse of a matrix, right? So if you calculate inverse of this, you're gonna get infinity. Why? Because I'm pretty sure the determinant of the matrix A is how much I taught you in part 5 or part 4 or part 6, I'm not remembering. So the determinant of this matrix must be how much? Must be 0, I bet. Because, yeah, it is. That's right. And why? Because I taught you that one of the rows is 0. This is the rule that I taught you. That's right. So the rows of this matrix is linearly dependent. This is linearly dependent that relates to the rank of the matrix, and you're going to deal with too much in the control theory. Okay. So, and the last one. So this problem is remembering too many problems to you in the Matlab. Okay. So the last problem is 1 minus 1000. Minus 1000, that's right, and 2, 99, 106, and 2.4, 0, and 1, and 1. This is in here. And your right hand side, or R, or you can say B, whatever you say, this gonna be oops, what happened? Okay, it's gonna be 1, that's right, 11, and for God's sake 60. So now your solution gonna be, again, what? Gonna be this number. So there's no need that you call this command. You say x is equal to, let me show you, yeah, x, because you can see it specifically, right? If you do that, you're going to get the same answer. So this is your x, this is your y, and this is your z. That's right. Okay, after solving a set of the linear equations, now it's the proper time that we solve for the linear and nonlinear equations, both as general case. So we use solve equation and the variable that you are trying to solve command to solve both linear and nonlinear equations. Okay. So what we're going to do first, when you are dealing with the solving equations, you have to symbolically define, let me show you clearly, symbolically show your variable in the Matlab. Sims is a command in Matlab that symbolically defines your, this is very powerful command in Matlab that when you're coding, a huge codes in robotics says, okay? So when you say sims x, after this, it gonna knows that x is a variable, it's just number, okay? Or say sims a means that the a is a symbolic variable, okay? Or you can define many of them, a, b, r, t, y, I don't know, I, or k1. So after this, a, b, r, t, y, I, k1, whatever they are, they can be solved symbolically. Where we are using specifically when as a mechanical engineering course. So when you're going to control the nonlinear control after in the graduation school, so in the control you're going to see you have to calculate for the nonlinear dynamics and nonlinear control, you have to calculate the Jacobian matrix. And Jacobian matrix is very around the equilibrium point. So you have to define your variables as a symbolic, that's right, because you want to have the analytical solution of that. Okay, I'm going to teach you eventually, okay? So now, so now here I'm saying that sims is x, that's right. Let me clean this because it's too much. Sims x, that's right. Now we're gonna this command gonna be the solution of and equal to solve. Okay, why I put it here? I'm getting older, guys. Okay, and cosine of x. This is the sign that 2 equals, okay, minus sine of x. And which variable that we are solving for? X. okay? And we set the x is a symbolic variable. So let me show you here, guys. So suppose this is the equation that I want to solve. Okay? Come on, what happened to you? Okay, so this is the equation I want to solve. Cosine of x plus sine of x is equal to 0. This is the nonlinear equations, right? So what I'm gonna do, I wrote like this: cosine of x is equal to minus sine of x. That's right, this is the same. But in MATLAB notations, I'm using two equals, okay? This is the language of the MATLAB. This recording is good. So, see guys? This is exactly this. But with respect to which variable? This is x. Here we go. So it says the solution x is minus pi over 4. Understand? Okay. So obviously it is minus 45 degrees because cosine of 45 or pi over 4 is root square of 2 over 2. So here root square of, it says it's minus pi over 2. Minus pi over 4 is equal to minus sine minus pi over 4. That's right. And we know from trigonometry this is this, and this is minus and minus plus. That's right, from the trigonometry. Here we go. That's right. So you see that MATLAB is very powerful on these kind of things. You can give any nonlinear equations and it can solve it for you. Okay, so as you see, these codes, let me move this here and you can see it. Oh, okay. Running, yes. Right. So as you see, and see, this code solves for the equation this. So run the code and find a solution as I did for you. Now let us do this. Okay, this equation we want to find. So what we're going to do again, because the x is, so now I'm saying that seems y. Don't think that always x is a variable. This is very common mistakes between the students. Open your minds, okay? So this is that the case. I have the command about there. So, but the equation 1 I'm talking about this is a y. I'm seeing here x, but I want to teach you that always don't stick to the x. And Dr. Payman taught us about the x. It can be any variable, okay? And the y, okay? And this is sine. Yes, everyone, okay? And y, bear with me. And this is tangent. That's right. Tangent of the x is equal to how much? 0.7. But equal to must be as 2 equal. And now your variable is y. You can put x, but I'm teaching you that don't stick to x always, okay? You have x here. That's right. So if you solve for this problem, this can have your solution, okay, in radian. So unable to solve symbolically, returning a numeric solution using a VPA solve, okay? So this is another command in MATLAB. Guys, MATLAB, when I was in the graduate students, MATLAB had more than 500,000 commands. I cannot teach you all of them, but I'm teaching the commands that you're going to use in the undergraduate and graduate courses in mechanical engineering, okay? So, and another one is, I'm sticking to the y. Let me change it now to x because you know the over here is x. So now it is x to the power of 3, x to the power of 3, x cubed, and sine of x plus sine of x. That's right. I'm talking about this, guys. Equation number 2 is equal to what? 2. And this is respective variable x. X cubed plus sine of x is equal to 2. So by using that VPA solve, this is the homework for you guys. Go and find, research it, or search in the Google or the Matlab help, what is VPA solve? This is another tool that Matlab gives. So this is the solution already, guys. Okay. So and now 3. So I'm saying that I'm changing the variable to the z. Do you care? No. Huh? So the solve is z in power of 0.5. That's right. This is z power. In sine of z multiplied by cosine of z. Do you care? No. And what variable is? Be careful. Variable is z this time. Okay. I'm just changing to expose you to the different scenarios. Okay. So and here we go. And I'm sorry. The solution is this. Okay. Understand? So another number 4. Let me stick to the z because I'm saving the time. This is number 4 I'm solving for. Okay. Okay. So it's gonna be 1 divided by, okay, z square plus sine of z. Right? Here we go. Is equal to 2.4. So this is going to give this solution. Understand? So and now number 5. I can make it a little bigger, but you can see it. This is number 5, guys. Okay. So again, sticking to the z, it's gonna be z or x sine of z in cosine of z, and plus tangent of z square is equal to 11. See that? This is where that. Okay. You have to be very careful about the brackets and the the brackets. Okay. So this is this equation that gives you this solution. Okay. Understand? So if you now guys, let me implement this inside that relation. Okay, I'm saying that now your z is equal to sol. Z is equal to sol. Your z is this. Now if I want to see if I put inside here the original equation, does it give you 11? Let us see. Yeah, it gives you 11. Understand? So that's the value of the z. Now number 6. Here we go. Okay. Number 6 is again, I'm now saying sims x. Oh, sims x. Okay. And now we can again solve. The equation is x squared plus 4.5. Don't write this. This is a mistake. Multiplied by z. Okay. This is 1.5. And oh, these are x, guys. I changed the variable to x. Okay. Here we go. It gives you 2 solutions. One of them is this, another one is this. So it means that this equation has not a unique solution. This is a serious issue in the mathematics, that uniqueness of the solution is very important, specifically for the stability in the control. Okay, so look at this solution of solution 1 and 1. Solution 1 and 1 can have this value. Understand? So if I say we have some commands. If I say pretty ants, it kind of gives me this how it's right as you're writing with your hands, right? If I say simply phi ans gravity distance, right? So pretty writing as you're writing with your hands, okay? Scrolling, yes. And we are, I'm saving time, hold on. Okay guys, so now, okay, now let me go again because it was too much things. So suppose that your sims is at number 6. So after solving this, okay, you can say this double solution. It kind of gives you the final answer after simplifying and multiplying and scoring, whatever it is, okay, in the power of. It gives you final answer. So double, gonna write like this. So double, that's another. So pretty likes, pretty sol, gonna gives you, this is how you write by your hand. That's right. This is very important commands in Matlab. Okay, interesting to know that we can symbolically also solve the equations. Run the following code, guys. It's very interesting. Look at here. So here we go. Okay. Clear. As I told you, you can say symbolic A, B, C, D, and X. That's right. I'm defining 5 variables like symbolically. Now I said equation, this is the command, is equal to A x to the power of 3 or cube plus B multiplied by x square power of 2 plus C in x plus D, that's right, is equal to 0. Don't forget, when I say equal to in Matlab means this command, 2 equals, okay? This is the equation that you get, okay? So on the other hand, I want to solve this equation. See here? A x cubed plus B x square plus C x square plus CX is equal to 0. I want to solve symbolically in Matlab. Okay, so I transferred everything based on this one. I'm plus D, I'm sorry, and let's see, I'm missing plus D. That's right. So this is the command that you can have it. That's right. So now after saying that the A, B, C, D, they are symbolic variables, you can say now solve again, now equation, and your variable that you want to find based on A, B, C, D is X. That's right. The variable that you are trying to find is X, as in the high school. So, oh, there's a typo here, guys. Equation. Okay. Now, here we go. This gives you, because the third order equation, there were 3. What? 3 solutions. That's right. So if I say, let me see, if I say pretty solve, it's gonna give you the solution. That's right. Root of this. So it solves for you. Okay. Understand? Okay, guys. I think now let's go for the let me see. Okay, guys, as you saw in the so as you saw in the see this here, so as we did we didn't get the specific solution. Okay, so what you're gonna do, you're gonna use this command now. Okay, this is the new version of the Matlab. So Now this is the equation x that we had until this point. So if you say max degree 3, because it's a third order system, so you're gonna get this solution. Understand? So if you say pretty sol, this is gonna be your solution, guys. Let's move it up. Okay, so this is gonna be 1, 2, 3 solutions, where number 1 is this and number 2 is this, and you have to replace there. So this gives you a symbolic solution of Matlab. So let me solve another problem. So if says is sims of z, now I want to solve this equation, z square, okay, plus simplify, plus c in z, and plus, that's it, is equal to 1.5. Now if I solve this equation, and the variable is z, that's right, the variable is z. Oh, let me make it smaller. Okay, the variable is z. So it's second order, I'm gonna say 2. Okay, it's empty, that's right, it's empty. It says there's no solution for this, that's right. So now if I say the solution of this, first of all, sim c a and c. Okay. Now if I say the solution of this in sine of z is equal to 0. I want to see what's this. Again, this has no solution because it's obvious. Okay. So, and that's it, guys. That's it. So, and I forgot to tell you, the empty means there's no solution exists for this, because you cannot solve this symbolically. That's why this is very, very complicated equation symbolically. Okay, so see you tomorrow.